Today we're going to talk about evaluating functions. And the first thing I like to think about is, what is a function? Because if we don't know what a function is, it's kind of hard to do everything else with them. So a function is something that takes inputs and tells you how to get to the outputs. So I like to think of it like this. I like to think of a function as kind of like this idea of a factory. In a factory, you put stuff in the factory and then you get different things out. So I might put a number like 3 in and get 5 out. So what's the function doing? Oh, the function is adding 2. So it really is a set of instructions on how you take one number and get to another number. So that's the idea of a function. So I might have a function that is f of x. So that's how we say in math, that's how we say something is a function, where x is your input, and they'll tell you the rule. So they're saying, okay, we'll take the function f of x, and our rule might be x plus 2. And that's telling you to take any number x, and when you take that number x, you add 2, and you get the final answer. Now you might think, okay, if the set of instructions makes something a function, like an idea of a function would be something like this. Let's use that example that we had before, 4, 5, and 7. So it takes all these numbers and it maps them. You might think, well, what is not a function? This would be an example of something that's not a function. See how our inputs are over here and our outputs are over here? And it says that we have one single thing that has 2 outputs. I like to think of this idea as like addresses. Like if you ask me where I live, I would generally say one place. If you say 2 different places, it kind of breaks down that pattern or breaks down that function. So a function is something that can only have, for every one input, it has one output. In this case, this thing would not be a function because I have one input but 2 outputs. Okay, so this thing would not be a function. Let's now look at some function examples. So we're going to have the function f of x equals 2x plus 7. So we're going to look at this function and kind of work with it. Okay. A problem that you might get might be f of 2. When we say that, we're asking this question. We want to know, what would I get if I input 2? That's really what we're asking with this. We want to know, like when we read this, this should be read as, what would I get if I input 2? So let's take this example and kind of look what would happen. So I'm going to erase this really quick. So we want to know what we would get if we input 2, and we're just going to kind of write that in. So we would get 2. And so x was the old thing, and you can see that's my input stuff. So instead of writing x down, we're going to write 2 plus 7. Well, when I have that, I would get that f of 2 is equal to 4 plus 7, which would give me 11. So I have just evaluated this function. They wanted to know what I would get when I input 2 into this function, and we would get 11. And that would be my final answer. Let's look at another one. Okay, so let's say this is now our function, and they want to know what we would get if we inputted in -3. So if I inputted -3, we'd rewrite this, and I'd have 3 times -3 plus 4 minus 7. And again, this was x before, and this is x over here, so we're just going to put in -3 for our input there. when we do this, I'm going to get f of negative 3 is equal to, well, 3 times negative 3 is negative 9, plus 4, minus 7. These square lines here are absolute values, so we want to do everything in the absolute value to start with, and then we'll deal with the absolute value near the end. That's going to give me that f of negative 3 is equal to, well, negative 9 plus 4 is negative 5, and that's still in the absolute value. And then we're going to get f of negative 3 is equal to, well, the absolute value of negative 5, absolute value is a distance, so it can't be negative, and it asks from the distance from 0. So negative 5 is 5 units from 0, so that changes it from a negative to a positive. And then we'll have 5 minus 7, which we know is negative 2. So we would find our answer here, that f of negative 3 is equal to negative 2. Let's do one more evaluating function. In this case, let's figure out what f of negative 1 would be. Well, again, this one might look weird because you go, oh no, I have two x's. Well, that just means we're going to input negative 1 into two spots. So for every x, we're going to input our input. So we're going to get 2 times negative 1. And notice I put parentheses when I put in my x. It kind of helps me keep everything together. It's negative 1 minus 3. Now we'll kind of go through and do the order of operations. So I should deal with the exponent first. When I deal with that exponent, I'll get that f of negative 1 is equal to, well, negative 1 squared is 1, so 2 times 1, whoops, can't write today, plus 7 times negative 1 minus 3. We're then going to multiply, because that's going to come before adding, so we'll multiply these two things together. I'll get f of negative 1 is equal to 2 minus 7 minus 3, because 2 times 1 is 2. 7 times negative 1 is negative 7, and then minus 3. Then we will add those things together. This would give me negative 6 minus 3 would give me negative 9. And that would be my final answer. This is how we evaluate functions. We find our x, we plug in our negative number, and then we just see what we get. We're going to look briefly at one more idea, which is graphing, which we really won't do a lot of tomorrow, but it is useful to touch on. Let's say I was given this function and they wanted me to graph this function. Now before, I've been giving you all your inputs, like I would say f of 2 or f of negative 1, like those were what we were using in the videos. Well, I kind of pick those numbers at random. So for most functions, you can actually input any single number. So if we want kind of a representation of every number that could go through this function, you kind of make an XY chart. And what you do is you just put in some numbers for x, so maybe 1, 2, and 3, and then you just plug them into here and see what you get. So if I plugged in 1 squared times 2 is 2, plus 7 is 9. 2 squared is 4, times 2 is 8, plus 7 is 15. And then 3 squared is 9, times 2 is 18, plus 7 is 25. So you can kind of see we can keep this chart going. Well, now that I have an x and a y, we can think of this as kind of our coordinate plane and count out 9 tick marks and go up 1 over 9. I think I did 9, 1, 2, 3, 4, 5, 6, 7, 8. Whoops, one short. 9. And then we could do it for the next point and the next point and start seeing the graph of the shape as we kind of go along. I don't actually know what the graph would look like. Sometimes these graphs can be helpful, though, in another way. So let me show you a quick example of this. So maybe I have this as my function. So instead of giving you an equation for the function, I gave you guys a graph. So that is now my function. And so I might ask you, well, what is f of 1? Now you might go, well, that's really hard to do because I don't have any formula to plug 1 into. Well, now we don't plug it in, we kind of look. So on my graph, I know this is my x-axis and this is my y, so these are my inputs, and this is my output. And if I go over to 1, I can see if I go over to 1 and up to 1, that if I input 1 into here, I get 1 as my output. I could do this with other numbers that were given. Let's go to -2. Well, we could see that if in this graph, if I go over to -2, I'd go down to -2. So that's that output there. It's at -2. We could do this for f of 3. Because we could see if I go over to 3 on my x's, my output would be up here at 1. So a graph is another actual good way of being able to look at a function without the same kind of rules that we were given before. So I don't necessarily need to have one of those. Is if I have a picture, I can go over to my inputs on this x-axis and out to my outputs on this y-axis. That's actually the main reason we graph functions, is so that we can see all their possible inputs and outputs without going through a tedious formula like this. So you might see some examples like that today. If you have any questions, please write them down so you can ask tomorrow in class.